Okay, so at this point we finished chapter 4 and we're in chapter 5 now. And now we're basically going to take a lot of the ideas we had in chapter 4 as far as our definitions of sine, cosine, secant, cosecant, and all of that, as well as some of the fundamental identities that we have mentioned. If you remember when we did the unit circle, we talked about the Pythagorean identity, sine squared plus cosine squared equals 1, and a few other identities like that. And we're essentially going to look at them algebraically, and basically, for lack of a better way of saying it, we're going to mess around with them a little bit for a while. We'll get to work on our algebra skills as well as our knowledge and understanding of these basic trigonometric properties that we have. And I just wanted to work through a few of them because it's essentially an algebraic skill and it comes with practice. So I just wanted to run through a bunch of them so we could kind of start to see how to solve them and then practice them over and over and over again. So, for an example, we're going to start with this. We want to simplify secant squared x, cotangent x, cosine x. And just real clear, because we're going to do this algebraic stuff in several different ways, and on Alex and in your books, your book, it'll appear different ways. Mathematically, when we say simplify, essentially what we mean is simplify maybe like a fraction. You have a fraction, you reduce a fraction as much as possible. Same thing here, reduce that as much as possible. Get rid of any common terms, make it as small as possible. And there's different ways to do it. And again, like I said, it mostly boils down to your knowledge of basic trigonometric principles that we've gone over, as well as algebra tricks that we'll kind of see as we work through these. First off, we have secant squared, cotangent, cosine. All things being equal, people generally understand sine and cosine better than they do the other trig functions. So a lot of times what we'll do first to simplify this is put everything in terms of sine and cosine. So say secant squared, that's the reciprocal of cosine. So the secant squared is actually 1 over cosine squared. X. Cotangent, it's a reciprocal of tangent. Tangent is sine over cosine, so cotangent is cosine over sine. Cosine x over sine x, all times cosine x. And now you can multiply this out. This is just regular multiplication of fractions, or we'll actually simplify now because just like multiplying fractions, you can simplify before you actually multiply. And if we look right here, this cosine x will cancel the square because it's cosine squared. This cosine x will cancel the other cosine x. And when we multiply everything out then, we're left with 1 times 1 times 1, which is 1, over 1 times sine x times 1, which is sine x. And then from there, if I want, let's see, 1 over sine x, sine is the reciprocal of cosecant. So that's just cosecant x. That one is pretty straightforward and simple, but that's essentially what we're going to be doing. Taking trig functions, rewriting them, manipulating them, and making them smaller and simpler. One thing I would point out, and I will stress this as we go through a lot of these problems are designed for you to be able to simplify them, which means they will simplify algebraically in some way. It's kind of up to you to figure out how to do it. But it shouldn't take like 412 steps to get through it because they're set up to work nicely for you because the goal is to practice what's going on. So, let's try another one. Let's see, suppose we have cosine x over 1 plus sine x plus tan x. Okay, and we're going to simplify this one too. And again, the question becomes, how do I simplify it? Well, if I had fractions, if I had something like 1/2 plus 1/3, if I told you to simplify it, what would you do? You'd add them together. You'd find a common denominator, multiply appropriately, and simplify them by just adding them together and solving the problem. So do the same thing here. let's see. I suppose if we want first, we could do that, but what we said last time, tangents, we can write in terms of sine and cosine. Maybe that's easier. So maybe we'll rewrite this first as cos x all over 1 plus sine x plus tangent is sine x over cosine x. Now add them together. Find the common denominator. Well, when we had 1/2 plus 1/3, your common denominator is 6. You just multiply them together. So same thing here. My common denominator will just be 1 plus sine x times cos x. And we're going to be doing a lot of algebra here. And unfortunately, this board doesn't give us tons of room to write it out. So I'm going to have to move down to another line. But you guys know how this works. My common denominator is going to be 1 plus sine x times cos x. And now how do I get that? This is a 1 plus sine x, so I need to multiply by cos x. I multiply on top and bottom. So I get cos x times cos x, which is cos squared x, cosine squared. Here, I already have the cos x, so I need to multiply by 1 plus sine x. So here, just to make sure I write it correctly, I get sine x times, in parentheses, 1 plus sine x. And there we go. Again, I have limited amounts of room on this board, but all we did was multiply appropriately to get my common denominator. All of you know how to do that. Now simplify. Let's see, right here, distribute my sine x. So I get cosine squared x plus sine x times 1 is sine x plus sine x times sine x is sine squared x all over 1 plus sine x times cosine x. If you want, you could multiply these out, but right now, just leave it as it is, and if we need to multiply it out later on, we will. But now, where do we go from here? My numerator is cosine squared x plus sine squared x, and now there's actually a trick, and this is a standard trick that we will use 100 times the rest of this semester, so good to kind of recognize it now. Right here in the numerator, we have cosine squared x plus sine squared x. That's my Pythagorean identity. Sine squared plus cosine squared equals 1. So I can replace that with 1. And then this becomes 1 plus sine x all over 1 plus sine x times cosine x. But now we see what we can do. Now we have a common 1 plus sine x on top and bottom. Cancel it out. And all that's left is 1 over cosine x. And let's see, cosine x is reciprocal of secant, so 1 over cosine is secant x. And there we go. So again, as far as tricks go, if you have two terms like this, two fractions, this isn't a fraction, but we can convert it to a fraction, but two terms, two fractions, write them as one. Find a common denominator, combine them, and then go from there. And then pretty much anytime you see sine squared plus cosine squared, immediately change it to 1, Pythagorean identity. And that will help you simplify things out. So tricks you can use. Good. We're going to look at another one now. Let's see, what do we want to do next? How about tan squared x minus 1 over tan x sine x plus sine x. Okay, now what do we do with that? Well, as far as it goes, again, we're using trig now, which makes this stuff look different. It's really no different than any of the algebra you've ever done before. And what I mean is, if you go back to 171, if I wrote something like x squared minus 1 over xy minus x, or something like that, you would all immediately do the same thing. You'd say, oh, that's a difference of squares, I can factor it, there's a common factor there, factor it out. Do the same thing here. Let's see. My numerator is tan squared x minus 1. That's a difference of squares, just like x squared minus 1. So it factors as tan x plus 1 times tan x minus 1. My denominator, tan x sine x plus sine x, well that's just xy plus x. There's a common factor of sine x. So factor it out. And you get sine x times tan x plus 1. Well, now again, we have everything kind of factored out. Cancel common factors. Tan x plus 1, tan x plus 1. And now we get, well, let's see. Tan x minus 1 all over sine x. From here, there's different things you can do. We don't necessarily like tan because we prefer sine and cosine. So I can rewrite that in terms of sine and cosine. And since I have two terms on top and one term on bottom, I can break this up as two separate fractions. In the same way, again, if it looks a little bit unclear, in the same way that 3 plus 4 over 8 is 7/8, I can write that as 3/8 plus 4/8, which is still 7 over 8. Same idea here. I have two terms on top, one term on bottom. So maybe to make it simpler, I'm going to break it up as two terms. So I'm going to get tan x over sine x minus 1 over sine x. We said I can write tan as sine over cosine. So that's going to be sine x on top, and then the cosine x goes on bottom and gets multiplied by the sine x. Okay, so if you're a little unclear, sine x over cos x is tan x, and then I have the other sine x on bottom. Minus 1 over sine x. Now, again, in the first fraction, I have sine x over sine x. That cancels out, and I'm left with 1 over cos x minus 1 over sine x. And again, these are just our reciprocal identities. Cosine's reciprocal of secant, so that's secant x, minus sine's reciprocal of cosecant, that's cosecant x. And there we go. So again, different things we can do, but essentially it's the algebra you already know. It may look different, but it's the same. Difference of squares, common factor, and then all we're really using is, well, the fact that I don't like tan, so I write it in terms of sine and cosine. I'm aware that this takes a bit of practice, because essentially they're algebraic skills that you have to develop by using them. So I'm going to make another video doing even more of this just to give you as much visual practice of me doing it as I possibly can.